Byron is investigating the monthly data usage of two different smartphone models. He randomly selects a sample of 14 users of each model and records their monthly data usage in gigabytes as shown in the table. The average data usage is 7 gigabytes for one person for each phone model. We're going to use a graphing calculator to find the z-scores rounded to 2 decimal places and use that to determine if 7 gigabytes is a more unusual amount of data for Model A or Model B. To do this, we're going to start by going into our stat and edit to get to our list, and we're going to put each model into its own list. So for Model A, we have 7.2, 5.9, 6.5, 7.8, 6.0, 7.5, 6.8, 7.1, 6.2, 7.0, 7.4, 6.3, 6.9, and 7.3. And that is 14 data values. Now we go over to list 2 and we're going to repeat this process with Model B, starting with 6.8, 6.7, 6.5, 6.9, 6.6, 6.4, 6.7, 6.3, 6.8, 6.5, 6.4, 6.6, 6.7, and 6.9. So again, 14 data values. Now, to know our z-scores, we first need to figure out what are our sample standard deviation and sample mean. So we're going to go into stat and calc, and we're going to choose one variable, statistics. We're going to start with list 1, but we will repeat this process with our second list, and we're going to calculate it. So for A, I'm just going to write it right up here. Our X bar, according to our calculator, is 6.85. And our sample standard deviation, again, according to the calculator, is 0. I'm going to give this a couple of extra decimal places just so we don't have too much rounding. Let's do 0.589. So this is the, again, sample mean and sample standard deviation for Model A. Let's do it again, but this time for sample B. So we want to know our mean, we want to know our sample standard deviation. So we go into stat, calc, one variable stats, and we're going to replace list 1 with list 2. So now it's going to look specifically at our values here. So now our mean is 6.63. And our standard deviation, again, we're going to just do a little bit extra on this because it's a small number. 0.1898 is going to round to 0.190. Now that we know our mean and our sample standard deviation for each of the models, we can calculate the z-scores in each case. So let's start with the z-score for Model A. So we're going to have our X value minus X bar over standard deviation. Now our X value is that 7 gigabytes. We're going to subtract our average for Model A, which is 6.85. And we're going to divide by the standard deviation, which is 0.589. So we can do this in our calculator. I'm going to do second quit to get back out to the main menu. And because I like it, I'm going to use the fraction method in the calculator. I'm going to hit alpha and y equals. That pops up this menu that lets me type into a fraction. I'm going to type in 7.0 minus 6.85 into the top of the fraction, then arrow down to 0.589. Remember, if your calculator doesn't have that capability, you would just use parentheses as we've done in the past. But this gives me that the first z value is 0.25, and we're rounding to the nearest 2 decimal places, so we can stop right there. And then we're going to repeat this, but with the values for Model B. So again, we go into our fraction form. we have our X value is 7 minus the average here was 6.63 and the standard deviation was 0.190. When we plug that in, we get that our z-score is 1.95. So what that's telling us here is that for model A, our 7 gigabytes is within 1/4 or 0.25 of a standard deviation of the mean. So it's pretty close. On the other hand, in model B, since our z-score is 1.95, we are 1.95 standard deviations away from the mean. That means model B, that is a more unusual amount of data usage.